Welcome to a behind the scenes look at how these videos are generated. Let me show you how it works. This is a behind the scenes video. Not a Python lesson, a look at how the Python lessons themselves are made. I walk you through the entire pipeline, how a lesson idea becomes a finished MP4 on your screen. We cover the architecture, the files, the tools, the workflow, and where we could improve. If you ever wondered what happens between typing a lesson plan and watching a video, this is that story. From idea to MP4. Here is what we build. Slow, atomic tutorial videos, one concept per video, 8 to 20 minutes each. 112 plan lessons in Phaso alone. Every video is fully reproducible from its source files, you can rebuild any video from scratch with one command. The cost is cents per video for Amazon Polly text-to-speech. The tools are Python, Pillow for slides, Polly for voice, Mpeg for assembly, Gemini for hero images, and Mermaid for diagrams. Cents per video. Fully reproducible. Every video starts here, a folder, a script, and a set of tools that turn text into a finished MP4. Think of it as a digital workshop. Every tool has a job. Here is the full pipeline in one picture. It starts with the curriculum, a markdown file listing every planned lesson. Each lesson gets its own folder with a content file that defines the narration. A self-scan checks for meta leak before any audio is generated. Mermaid diagrams are rendered to PNG. A scaffold script writes the narration JSON, copies shared templates, and calls Gemini for hero images. Then the build script generates slides with Pillow, synthesizes audio with Polly, renders segments with Mpeg, and concatenates everything into the final MP4. The whole system in one view. The repository has two zones. The first is the factory, a shared folder called _factory that holds templates and utilities, the slide generator, the video builder, the duration estimator, the Mermaid theme config, and the brand open and close images. The second zone is the lessons, numbered folders, one per lesson, each fully self-contained. Every lesson folder has its own content file, scaffold, slides, audio, and output. You can rebuild any lesson from its own folder without reaching into the factory for content. Factory plus lessons. Here is what lives inside a lesson folder. Scripts holds the content file where we write the narration, the scaffold that orchestrates everything, the generated narration JSON, and copies of the shared slide generator and video builder. Diagrams holds the Mermaid sources and their rendered PNGs. Slides holds the Pillow generated teaching slides. Inserts holds the open and close brand images plus any Gemini hero images. Audio holds one MP3 per segment. Output holds the intermediate segment MP4s and the final deliverable. Self-contained and rebuildable. Before any video is made, there is a curriculum. 112 planned lessons, each with a clear stopping point. The curriculum is the blueprint. The narration JSON file is the heart of the entire system. It is generated by the scaffold from the content file, and it drives every subsequent step. The slide generator reads it to create PNGs. The video builder reads it to synthesize audio and render segments. Each entry in the JSON has an ID, a kind, slide or insert, a title, optional bullets or code, and the narration text that becomes speech. Change the JSON, rebuild, and the video updates. One file drives everything. The factory folder holds 6 shared assets. The slide generator turns JSON into 1920 by 1080 PNG slides using Pillow. It handles titles, bullets, code blocks, and embedded Mermaid diagrams. The video builder calls Polly for text-to-speech and Mpeg for segment rendering and concatenation. The duration budget script estimates video length for free before any Polly call. The Mermaid theme JSON defines the dark coarse palette, cyan borders, mint arrows, dark blue panels. And the brand open and close PNGs set the visual identity for every video in the series. Shared assets, copy once. Step 1. Everything starts with the curriculum, a markdown file that defines every planned lesson. Each lesson has a catalog number, a topic, and a clear stop point. The rule is one concept per video, no pile on. If a lesson tries to cover 2 topics, it gets split into 2 lessons. The curriculum is the blueprint for the entire channel. Without it, we are just making random videos. It starts with a plan. Step 2. For each new lesson, we create a folder with the naming convention NN Python topic, a number, the word Python, and a kebab case topic name. Inside the folder we create subdirectories for scripts, slides, diagrams, inserts, audio, and output. Then we copy the shared templates from the factory, the scaffold, the slide generator, the video builder, and the brand open and close images. One folder equals one lesson, fully self-contained and rebuildable. Structure first, content second. Step 3. We write the content file, script/content.py. This file holds every slide definition as a Python dictionary. Each slide has an ID, a kind, slide or insert, a title, optional bullets or code, and the narration text that will become speech. The narration is written in teacher voice only, no producer jargon, no mentions of slides or diagrams or pipelines. We target 340 to 420 characters per teaching slide, which translates to roughly 22 to 28 seconds of audio. 5 layered defenses prevent meta leak, the accidental inclusion of production terminology in the spoken track. Teacher voice, always. Step 4. Before any poly call, we run the content file directly. The self-scan checks every narration string against a band list, diagram, flowchart, sequence, mermaid, slide, panel, bullet, on the screen, this visual. If any word is found, it prints a meta warning with the slide ID and the offending words. We fix the narration and rerun until the output is clean. This prevents the most expensive mistake in the pipeline, synthesizing audio that mentions the production process. Catch leaks before they cost money. Step 5. For lessons that need visual explanations, flowcharts, decision trees, data structure anatomy, we author Mermaid source files with the .mmd extension. We render them to PNG using the Mermaid CLI, passing the shared theme config so every diagram uses the same dark palette, cyan borders, mint arrows, dark blue panels, smooth basis curves. The output is scale 2 for sharp 1080p embedding. The .mmd file is the source of truth. We edit Mermaid, re-render, and rebuild the slide. Visual explanations, themed. Amazon Polly turns our written narration into natural speech. The audio becomes the master clock for the entire video. Polly gives the videos a voice. Step 6. The scaffold script reads the content file and orchestrates everything. It writes the narration JSON, the heart file that drives the entire build. It copies shared templates from the factory. It calls Gemini Nano Banana tool to generate hero images if the hero's flag is set. And it calls the build script for the full Poly plus FMPEG build. One command, scaffold.py-heroes-build, does everything from content to finished video. One script, one command. Step 7. Hero images are decorative stills that break up the teaching content. Each hero follows a consistent prompt pattern, cinematic 16:9, no text, no watermarks, no readable UI, with a theme-specific description, dark desk or abstract geometry, cyan and mint accents. We generate them with Gemini Nano Banana tool at 1K resolution. Hero images are never used for teaching content, they are breathing room between code-heavy sections. The prompt explicitly bans readable text because AI image models produce garbled glyphs. Decorative, never teaching. Step 8. The slide generator reads the narration JSON and creates a 1920 by 1080 PNG for each teaching slide. It handles 4 content types: title slides, bullet lists, code blocks, and embedded mermaid diagrams. Code blocks auto-scale the font size from 28 down to 16 pixels to ensure long code never falls off the slide. Basic syntax coloring highlights keywords in cyan, strings in mint, and comments in muted gray. The footer shows the lesson name and page number. Every slide uses the same dark palette, high contrast for video. Exact pixels, not AI guesses. Step 9. Amazon Polly turns our written narration into natural speech. We call AWS Polly TTS tool synthesize for each slide, using the Matthew Neural voice. One MP3 file is generated per slide ID. Audio is cached. If the narration text is not changed, the existing MP3 is reused. This means rerunning a build after changing a slide only synthesizes the changed slides, saving time and money. The cost is approximately 5 to 15 cents per full video. Cached, cheap, neural quality. FMPEG assembles each segment, one image held for the exact duration of its audio, then concatenates them into the final video. FMPEG does the heavy lifting. Step 10. This is the most important design decision in the entire pipeline. Audio is the master clock. Each segment is self-contained, one image held for the exact duration of its audio, plus a small pad. The FMPEG command loops the image, measures the audio duration with FProbe, and renders the video for exactly that long. Soft fades in and out, about 0.35 seconds, smooth the transitions. There is no global timeline, no fragile cut points. Each segment is independent. If one slide's narration changes, only that segment is re-rendered. The most important design decision. Step 11. For each slide in the narration JSON, FMPEG combines the image and audio into one MP4 segment. Insert slides use the hero or brand PNG from insert/stills. Teaching slides use the Pillow-generated PNG from the slides folder. All segments are 1920 by 1080, 30 frames per second, H.264 video with AAC audio. Each segment gets a soft fade in at the start and a fade out at the end, creating smooth visual transitions without any NLE editing software. Independent, replaceable, clean. Step 12. The final step. FmpEG's concat demuxer joins all segments in script order, first a stream copy pass that is nearly instant, then a re-encode pass with constant rate factor 18 for quality and plus fast start for web streaming. The result is a clean MP4 with proper timestamps, ready for YouTube or any video platform. The build script prints the final path, duration, and file size. Web-ready output. 6 design decisions make this pipeline work. 1. Audio is the master clock. The video duration is always driven by the audio, never by a fixed timeline. 2. One-shot poly. We synthesize once and accept the length, because resynthesizing risks reintroducing meta leak. 3. 5 layered defenses prevent production jargon from leaking into the spoken track. 4. Self-contained lesson folders mean any lesson can be rebuilt from its own files. 5. The shared factory means fixes to templates propagate automatically on the next scaffold. 6. The open and close brand images set the visual identity for the entire series. 6 decisions that make it work. The result, a polished tutorial video, fully reproducible from source files, costing cents to produce. Under $1 per video. Here is where we could improve. On visual quality, we currently check code overflow manually. We could automate it by measuring text bounds before rendering. We do not have visual regression testing, comparing slides across rebuilds to catch unintended changes. Our syntax highlighting is basic regex, not a proper tokenizer like Pigments. We have one dark theme, different series might want different looks. And we generate no thumbnails, YouTube requires them, and we create them manually. We check manually. We should automate. On workflow, we could batch generate content for multiple lessons with automated quality gates. The self-scan is already a gate, but we could add more. We could use an AI subagent as a narration reviewer, fresh eyes on the teacher voice before Poly. We could generate subtitles automatically from Poly's timing data. We could generate YouTube metadata, titles, descriptions, tags, from the lesson content. And we could set up C/CD to rebuild and verify videos on every Git push, catching regressions early. Faster, more reliable production. On content, our code blocks are static, we could animate them with a typing effect. We type IPython output manually, we could capture real sessions instead. We have no background music, a subtle bed under the narration could add polish. We cannot show code and a diagram side by side dynamically, picture-in-picture or split screen could help. And for a web version, we could add interactive elements, clickable code, quizzes, progress tracking. Richer, more engaging videos. Here is the full pipeline in one breath. The curriculum defines what to teach. The content file defines what to say. The self-scan catches leaks before Poly costs a cent. The scaffold orchestrates everything. It writes the narration JSON, generates hero images, and triggers the build. The build generates pillow slides, synthesizes Poly audio, renders FmpEG segments, and concatenates them into the final MP4. One command, scaffold.py-heroes-build, turns written content into a finished, polished video. One breath, one pipeline. Here is the cost breakdown. Poly TTS costs approximately 5 to 15 cents per video. Gemini Hero images are covered by the free tier, about 100 images per day. FmpEG and Pillow are free, local tools, no API calls. Mermaid CLI is free and local. The total cost per video is well under $1. For the full Phase A, 112 videos, the total production cost is under $100. That is the power of a fully automated pipeline. Under $100 for 112 videos. And here it is, the one command that turns content into a finished video. Create the folder, copy templates from the previous lesson. Edit the content file, write the narration. Run the self-scan to check for leaks. Render mermaid diagrams if the lesson has them. Then one command does everything. Scaffold.py-heroes-build. It writes the narration JSON, generates Gemini Hero images, creates pillow slides, synthesizes Poly audio, renders FmpEG segments, and concatenates the final MP4. The result lands in the output folder, ready to watch. That is the whole system. Where could this go? Template variations for different course series, Linux tutorials, cloud tutorials, each with their own brand identity. Multi-language narration, Poly supports dozens of voices and languages. Automated playlist generation, The curriculum already defines the order. Integration with the YouTube API for direct upload from the command line. AI-assisted curriculum expansion, suggest new lessons based on what students struggle with. The pipeline itself is the product. The videos are the output. Every improvement to the pipeline makes every future video better. The pipeline is the product. Thanks for looking behind the scenes. The pipeline is the product, and it keeps getting better. Keep building.